Hello everyone, and welcome to your Chem 113 review on dilutions. My name is Jason, and I work for the ASU Tutoring Centers. So we're trying to essentially go from a 3.0 molar sulfuric acid solution to a 0.10 molar sulfuric acid solution. So we're trying to dilute it a lot. We're trying to reduce its concentration a lot. So what we're trying to ask is how many mils of this are needed to make this equivalent dilution. So we have to think about this. All we're changing is the number of liters of solution, or in this case, the number of milliliters of solution, okay? So we're not actually changing the number of moles of sulfuric acid. So the number of moles we have in our first dilution over here of sulfuric acid equals the number of moles over here. Well, how many moles of sulfuric acid do we have over here? As we saw in the previous video, if we take the molarity, the initial molarity, and multiply it by the initial volume, this gives us the initial moles. I'm using the little subscript I to mean initial. So what we had at the beginning over here. Now what about at the end? So our final number of moles would be M sub F times V sub F, our final molarity times our final volume. Because again, molarity times volume is moles. This is our final number of moles. So what do we say about these two things? Well, again, we're not changing the amount of H2SO4, the amount of sulfuric acid. All we're doing is we're changing the volume. So the number of moles at the beginning and the number of moles at the end have to be equal. Okay, so this is how you deal with dilutions. You just know that the initial molarity times the initial volume equals the final molarity times the final volume, because the moles have to be equal. So now let's plug in all of the information we have. So what's our initial molarity? It's 3.0 molar. What's our initial volume? Oh, well, we don't know. That's what we're trying to find. So I'm just going to leave it. What's our final molarity? It's 0.10 molar. And what's our final volume? It's 450 milliliters. Now, we could convert it to liters, because again, how is molarity defined? It's moles per liter. So we could leave it at 450. We could convert it to liters, because we'd kind of have to do that to cancel out the liters. But what we can do instead is just sort of, instead of trying to find moles, we can try to find millimoles. That is in fact a thing. So molar is defined as moles per liter. But if I just kind of shift both the top and bottom down by 10 to the negative 3, I could also define it as millimoles per milliliter. Millimoles just means 10 to the negative 3 moles. Again, that's what the milli prefix means, right? 10 to the negative 3. So if I were to take my 0.10 molar and multiply by my 450 milliliters, my answer over here would be millimoles. But that's totally fine, because then if I divide by the molarity over here, my volume would be in milliliters. So like I can just leave it as milliliters. I don't have to convert it to liters, because everything will end up canceling out anyways and give me a final answer in milliliters anyway. That's very common, again, with these sort of dilutions, with these sort of acid-base chemistry, with a lot of solution-based chemistry, is we leave things in millimoles, just because a lot of solution-based chemistry is very tiny, very, very tiny. So we just use millimoles instead. So we're trying to solve for V sub I here. So we have 3 V sub I's equals 0.1 times 450 is 45. Then divide both sides by the 3, and we get V sub I is 15. So that is 15 milliliters. Because again, we're dealing with milliliters over here. So over here would be also in milliliters. Okay, wonderful. As I mentioned at the beginning of the video, I work for the ASU Tutoring Centers. If you want more information about the free tutoring services we offer on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. If you go here, you'll be able to find a tutor on your campus or online that'll be able to help you with your specific course. Thank you again, and I hope you have a wonderful day.